important to understand is just that output compare mode unit. This is the unit which actually compares the value of my OCR0 to the TCN20 unit. So whenever a match occurs, then it generates it goes to the waveform generator. Waveform generator, depending upon our settings from the TCCR0A and OA and OB, which have their bits of WGM and COM. The COM is this compare match output unit. I will just come in a while. So depending upon these settings, our correspondingly output wave is generated on the OC pins which I have told you. Okay, so for using these pins, there is one thing very important, that we have to set output compare pins to the OX pin must be set as output before the actual output compare mode is being used. Okay, because they override the normal input output operation, and the use in the waveform generator is then enabled for those pins. Okay, so say the output compare unit is the one which compares, and this compare match output unit, this decides that after the comparison what will be the action taken. Like my OCNX pin will be its bit control, like it will be set to high, it will be set to low, it will toggle from low to high edge, or it will toggle from low to high to low edge, and all the compare this defining the output compare state at the next compare match. Okay, so this is the short overview. There is one more thing. All the features of timer 0 and timer 1 are almost same. There is just one more thing in the timer 1 module, that is the input capture unit. The input capture unit is very interesting thing. I will, in the upcoming videos, I will also show its practical implementation. It is basically used in like for the oscilloscopes. Like what does input capture unit do? It captures the input external events and give them a timestamp indicating time of occurrence. Now external event can be our falling edge, rising edge, or etc. So now just take a situation that we have to, there is a, like what we do in oscilloscope, we give it the external events, the external falling edge, rising edge, or binary waves, square waves, and all such things. So it catches those external events and map those external events on the basis of the timestamp. From the timestamp, what I mean, the external signal indicating an event or multiple events can be applied via the ICPN pin, or alternatively for the timer counter one only. Okay, so like for output compare match we have OC, and similarly for input capture we have ICPN pins. Okay, so these timestamps can then be used for calculation of frequency, duty cycle, and other features of the signal applied. So to understand this, just we will go through this block diagram and then we will wrap up the video. So now like this is my ICN pin which gets the external events like any falling edge or trailing edge, leading edge, anything. Then when it gets those event, that event, all those settings of the which event to capture is done from the setting and control registers of the timer. And when it get that events, the value, and as we know that TCNT always increments. Okay, for 16-bit there are two 8-bit registers, NH and NL. Combined, in the combined format we use them as TCNTN. Okay, so TCNTN always increments, and it has all the it increments from 0 to 65536. So now let's say my event comes at the value 10,000. When TCNT has 10,000 value in it, it is incrementing. So that value will go into the ICRN register, and this from this ICRN register we can calculate in our application program that what to do. Now I store the 10,000 in a variable A, then I again make its settings to capture another high signal. Let's say it comes at 11,000. So now I will store another value B on 11,000. So on these two values, 10,000 and 11,000 steps, I can calculate that what is my duty cycle of the signal, what is my frequency of the signal, and all such things. So when a change of the logic level occurs on the input capture pin, alternatively the 16-bit value of the TCNTN is returned to the input capture register, and the input capture flag is set at the same time when TCNTN value is copied to the ICN register. So this thing can be used for enabling our registers and for high frequency applications. Okay, so this the input capture is like from the pinout you can see the ICN pin is also there. This ICP5 and ICP4, these are all input capture units. Okay, so that's a quick overview which I want to give on the timers of the AVR microcontrollers, telling its mode of operations. There are basically three modes of operations in it: normal, clear time, fast PWM, and phase correct. Like these both come under the PWM mode. And for generation of these using of these operation, there are units in the timer peripheral like input capture unit, output compare unit, and the compare match output unit, and these all do their work according to the settings which we made on the TCCRO, TCCRA and TCCRB registers. Okay, so that's it for now. Now in the next videos I am going to tell you on how to use timer peripheral from the directly from the application basis. Okay, so not like a device driver, but we will create an application and then we will use all these features. So I hope you like the video. If you like it, then kindly subscribe the channel and do share it with your friends, and do mention down your views. They are very critical and they're very important. So that's it for now. Like the video, subscribe the channel, and press the bell icon to get notified for new videos, and share it with your friends.